An additional family planning screening test is non-invasive prenatal testing, or cell-free DNA, which we'll discuss here. My name is Cathy Lawson, and I'm a genetic counselor. I've had the privilege and honor of walking many a family planning journey with women just like you, and I am privileged to be presenting to you today. Non-invasive prenatal testing, or non-invasive prenatal screening, is something that many of you have probably heard about. It's offered by a variety of different genetic testing laboratories and is easily accessible to most pregnant patients. This is just a handful of the names of the tests that are the same technology. Cell-free DNA screening, also known as non-invasive prenatal testing, is a screening test of a blood sample from the pregnant mother. In this picture, you can see that this is the maternal bloodstream, the mother's bloodstream. The red circular cells here are whole cells of the mother, and they contain the genetic material of the mother. When cells divide to make more cells, the original cell dies. And when that original cell dies, it leaks its contents out. So we all have in our blood contents of our cells floating freely in our blood, including little pieces of our genetic material, or our chromosomes. So what you can see here is these purple double helix, or DNA, are small pieces of chromosomes that are basically junk DNA from dead cells of the mother. So she has her own whole cells, but she also has little pieces of DNA in her blood. A pregnant woman also has small pieces of DNA from the placental cells that have gone through division and died and leaked their junk DNA out. That comes through the placenta into the mother's blood. So essentially, a maternal blood sample has free DNA from the mother and free DNA from the placenta. 99% of the time, the placenta and the fetus have the same DNA. So what this test looks for is essentially the number of copies of certain chromosomes. Most commonly, this is a screening test for Down syndrome and other common chromosome conditions where individuals with those conditions have an extra or a missing chromosome. So for example, individuals or fetuses with Turner syndrome, where there's a single X chromosome, we can screen for that in the fetus by getting a blood sample from the mother, because we also in this test can screen for the number of copies of the X and Y chromosome. So this test screens for the number of copies of chromosomes 21, 18, 13, X, and Y. So in addition to looking for the number of copies of those chromosomes, it can also tell you the predicted genetic sex of the fetus. Here is an example of a portion of a lab report. This report will essentially say the result is negative. This is good news. That means that we see the expected amount of DNA in a maternal blood sample for the chromosomes being analyzed. Then there will be some breakdown of the results, including the predicted genetic sex of the fetus here in the top line that says consistent with male. And then any additional chromosome conditions that are screened for with negative results, or that a specific condition was not suspected or detected by the blood test. This blood test is not 100% accurate. If during pregnancy you want to pursue as accurate prenatal testing as possible, that would be by either chorionic villus sampling or amniocentesis. You can learn about those in more detail by viewing the separate modules. Here you can see the reported accuracy or sensitivity and specificity of this blood screening test for the various chromosomes. It's specifically for Down syndrome and has a very high sensitivity. In other words, it will detect virtually all the cases of Down syndrome. For trisomy 18 and trisomy 13, as well as for the number of sex chromosomes, looking for extra or missing sex chromosomes. The accuracy of telling us the predicted genetic sex of the fetus is also about 99%. Some important things to keep in mind is this is not a diagnostic test. This does not detect individual inherited conditions within a family, including the X-linked condition of interest. And it screens for a limited number of chromosome conditions. Even predicting the genetic sex of the fetus is not 100%. This could occur as a result of a couple of phenomena. One might be that the pregnancy started as a twin pregnancy, and very early on, one of the twins did not survive. And so now there's DNA in the mother's blood from a second fetus that we do not detect by ultrasound. Maybe that second fetus had a different genetic sex than the current fetus. That will skew the results. Additionally, we might see that the placenta has different chromosomes than the fetus. This is generally unusual for the sex chromosomes of the placenta and the fetus to be different, but in genetics, never say never. And of course, there can be other more rare circumstances that can occur as a result of some condition in the mother or the fetus. It's also important to keep in mind that the laboratory may not actually be able to do the analysis when they receive the blood sample. The testing is done generally beginning at as early as 9 weeks of pregnancy in the first trimester through the entire pregnancy. But the first thing that the laboratory needs to do is to determine what percentage of the little fragments of DNA in the blood come from the placenta versus from the mother. And there has to be a certain amount from the placenta in order for the laboratory to feel confident in the result that they're reporting out. If that amount of placental DNA, also called the fetal fraction, is less than the laboratory's cutoff, then they're not going to do the analysis. The results generally take about 1 week. We do not currently have widely available non-invasive prenatal screening on a maternal blood sample for inherited single gene conditions. There is some very limited availability at a handful of laboratories. The difficulty for this in the setting of the mother being a carrier for a genetic condition means that the mother's DNA floating in the blood will have that gene mutation in it, and that may skew the results of the fetus. So more testing on maternal blood may become more widely available that would more accurately reflect the fetal DNA in maternal blood for non-invasive prenatal screening or testing for inherited conditions. Currently, it's just a screening test for what it can screen for, and diagnostic testing is recommended as needed. Considering finances, this is generally considered an affordable screening test. If once pregnant, your health insurance covers maternity care, the cost of routine cell-free DNA or non-invasive prenatal screening is typically a covered benefit. If it is not covered by your health insurance, most laboratories currently in the year 2022 offer testing at a self-pay price of somewhere between $100 and $300. As this screening test becomes more widely available, the cost of testing is likely to decrease. What are some next steps? Your local obstetrician who's taking care of you in your pregnancy can order cell-free DNA or non-invasive prenatal screening. This is a routine screening test, and they will know how to order it. Be sure that you tell them that you want to include the predicted genetic sex of the fetus, given your risk to have a child with an X-linked condition. For a more detailed discussion of all of your family planning options, including cell-free DNA, genetic counseling is an available option, and a genetic counselor can be found at the link provided. You may also have a consultation with a maternal fetal medicine specialist. Best wishes.